Noisy energies in the room.
Very good, very good.
Yes.
My
Hi.
friend from Viavi, Georg, how are you doing today?
Very good.
Happy,
Thanks a lot,
excited,
Jose.
first ever epic meeting here.
Yes.
Fantastic. Welcome everyone. Wilfred smiling from Neuchâtel as usual. Dirk the man there in the Netherlands with the green background. Julia, our new Intel hero. Thank you very much for joining today. It was great that we engaged with email. I have to say, I contacted Julia yesterday. So sorry about that. Sorry about the short notice. We have a great meeting in front of us. It's going to be a fantastic, fantastic afternoon. I would like to let you know that we are here to stay. Nearly 40 million people in the world cannot see. We want to really start with a short promo video that we made for you. I think many of you saw the video online. I want to show it to you for those of you who haven't seen it yet. Nearly 40 million people in the world cannot see. Suppose we took what we learned from LIDAR and automotive and adapted the technologies to help restore eyesight. Friday, 12th of June, EPIC is organizing an online meeting to discuss what's already possible with structured light and computer vision, and what we could do together to accelerate the future. I expect crucial issues like eye safety, resolution, reliability, and price, as well as current and future applications, from face recognition to making you aware of a potential danger. Today's main application field is machine vision. Today's production lines demand imaging-based automatic inspection, analysis, process control, and robot guidance. So let's discover business opportunities for today and tomorrow. Today and tomorrow. And today is a fantastic, fantastic Friday afternoon. All of you are thinking, oh, my weekend is about to start. I would like to let you know that my weekend is also about to start. That's why I am wearing already my summer clothes. I am wearing my short pants and I'm excited to start my weekend. This is how I'm looking, because you only can see the top part, but I'm actually very comfortable. My guitar is just next to me, my Macs, and this is the number 28 of the EPIC Online Technology Meetings. We started on the 1st of April. We started on the 1st of April with femtosecond lasers. So far, we have covered so many topics, and what's most important, we're getting so many great amount of feedback from all the members of the industry. This is what is making us shine. This is what is making us so happy. At the same time, I have to say one thing. Not only we're making people happy, also we are getting a lot of companies asking us to become member of EPIC. So today we are 569 members of EPIC. I would like to welcome, in the last 24 hours, you got LIOCON and QS Laser to join the association. Sana, if we reach 600 before the 15th of July, what are you going to do for the public?
This is what I'm going to do. I think I should stop sharing so that everybody sees. I will celebrate, of course.
She's gonna celebrate the epic style that she deserves. I also would like to remind everyone that because you're an epic member, you have a long access to market reports, to events, and also that, as you can see from Sana, we are completely crazy. On the 24th of June, we organized the 24 hours of photonics. I'm going to be chairing an online meeting for 24 hours non-stop. And if I survive, we'll continue being epic afterwards. And when the whole situation, COVID-19, is over, which I think is almost over, we are almost in the normal situation now, we also already have planned great meetings in Q4 2020 and also in 2021. I would like to call your attention for a fantastic meeting that we're about to organize at Nanoscribe on advanced micro-optics on the 5th and 6th of November with the whole supply chain on different market segments. The agenda is already online. It's a top agenda. If you are around the area or you are anywhere in the world, change your plans, come to Nanoscribe on the 29th and 30th of October. I also got a lot of market reports because I really wanted to understand this market. So I bought a lot of market reports, which I'm giving to you for free. So I bought a market report on 3D sensors. I bought a market report on drones, a market report on smart glass, a market report on ADAS, and one on vision cameras. So all of this is now in the extranet, all for you. So you want to have a look, understand who is who in this market. Just use it, abuse it, because I did spend a lot of money on that. Also to remind you that we have the biggest website to find a job in photonics in the world, www.jobsinphotonics.com. We have actively scouted the job openings of the 569 members of EPIC, and they are all there. And that's it. Today, Today we talk about structured light and computer vision. I would like to thank first of all the sponsors, LioniX, all the way from Enschede in the Netherlands, silicon nitride platform for many photonic integrated circuits applications. But today they're going to talk to us about what they can do to scan light without moving parts. A fantastic company. And also Focuslight, recently they acquired LIMO, so now they can offer the whole supply chain from micro-optics all the way to laser solutions. So you need any kind of micro-optic manufacturing on any laser-based process, from ultra-fast to CW, from diodes to optics, Focuslight is the place to go. We put together an amazing agenda. Actually, a few months ago, I went to Paris. I went to PROPHESEE. I saw what they can do. I was amazed what they can do, and they inspired me to try to put a supply chain from all the different companies who can help a company like PROPHESEE making it big in this market. And that's the purpose of today, to show what PROPHESEE can do and also what other companies are doing similar things and what other companies can help these neuromorphic camera manufacturers doing things even better. And the supply chain looks like something like this. We have a few end users that talk to us about this market, like Roche or like Ericsson. We have companies who make smart Googles, like INOPTEC, Ralf, hello. We have companies who are making cameras in LIDAR, Beamagine. You're going to hear from them later, quite outstanding. Time of flight, Teravi, hello. Neuromorphic cameras, I talked actually in the last 48 hours, I talked to Insightness, I talked to Innovation, they're here in the room. I also talked to PROPHESEE quite a lot in the last years. And we have Viavi, which is now our key member for vertically integrated solutions. So much Viavi for joining the association. Of course, we already met Julia from Intel, and the idea is to bring the entire supply chain together, also adding the process for packaging, the micro-optics, the testing, the production equipment. Everybody is here, and the purpose of this beautiful afternoon, at least here in the Netherlands, is sunny and beautiful. The purpose is to find business connections. I would like, first of all, to say hello to the people who are watching us in YouTube, because we are broadcasting this meeting in the YouTube universe. So for those of you in YouTube, hello everyone. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will introduce you. This is valid also for the people in the Zoom room. If you want to get in touch with anybody in the room today, just send me an email, jose.pozo@epic-asoc.com. My passion is really to connect people in this industry. I will be more than happy to introduce you so you can do business together. And that was all I had to say. And now I want to leave the floor to the people who are really making a difference in the industry. I want to give the floor to the company PROPHESEE, who in the last years, everybody is looking up to, and everybody's looking also to find ways to collaborate with them because they're making a huge difference in this industry. Simone, thank you very much for being with us today. Thank you for telling us how we can do to make PROPHESEE the best, even better. The floor and the attention of everyone here and in YouTube is yours.
Thank you, Jose. Thank you for the introduction. Thank you for having me here. Let me share my screen. Right. Do you see?
It is coming, it is here.
All right, thank you very much. So good afternoon, everyone. I'm Simone from PROPHESEE, product director. PROPHESEE is a company, for those who doesn't know us, is a company with a headquarters in Paris. We design neuromorphic sensors and the artificial intelligence algorithms that couple with those sensors. Neuromorphic sensors are also known in the universe, say, as an event-based sensor, and they are designed to mimic the human retina, which means that every pixel in the sensor is independent, that activates itself intelligently and asynchronously, depending on the number of photons that are present in the scene. So basically what we detect is a change in contrast or light intensity, and we call this an event. That's the reason of the name event-based vision. So basically we automatically extract what is relevant in the scene. The concept of this type of sensors that we call metavision, so something that goes beyond conventional vision, is reported in this picture in the middle. So you have a photodiode which collects the photons, and then you have a sort of comparator which gives spikes only when you cross a threshold. It's important to say that this threshold is relative, and basically every pixel depending on the history, may have a different threshold than other. If we have a light intensity that change like this one reported in the picture, every time we cross this relative change, say plus 15 or minus 15%, we code with an event. We output an event. Event is XY of the pixel, so the position, the timestamp, and the polarity. So light intensity, positive or negative, so change, increase or decrease. And the output of the picture is something which looks like this one. So it's gray, so meaning no events where nothing changes. And then you have black and white dot where there is something that moves or change. Why we do that? Because we want to bring the human eye capability to machines like 360 degree. Can be autonomous driving, can be robots, can be industrial automation tools. The sensor design in this way is extremely fast. We have a time resolution which is 1 microsecond. We don't have any more exposure time, nor we don't have frames, so we are not blind in between two frames. The eye dynamic range is high. It's 124 dB, and this is basically embedded in the pixel, in the way in which the pixel works and the sensor works, and is also very sensible in low light. We measured the low light cutoff of 40 millilux. And also generates less data from 10x to 1000x, depending on what you're looking at. So like I said, we designed the sensor, but also the algorithm. There are many applications for this kind of technology. Today, what I want to talk about is structured light. So if you couple this metavision sensor with a VC cell projector or another kind of projector that can project a pattern, suitable pattern, we can realize an even-based structured light sensor. So why we want to do that? The reason is that today you have different technologies to capture 3D information. It can be stereo, active or passive, can be structured light, can be time of flight, can be LiDAR. Basically, in all the cases, you have some trade-offs, and one of the typical trade-off is between the exposure time that you have, the accuracy that you can get, and the robustness of the system. Robustness, I mean, against sunlight, for example. If you use an even-based sensor to do structured light, basically what you can get as a benefit is that the response is very fast. And so compared to standard system, we can have an improvement of 50x, so 1 millisecond to get the full 3D scan versus the conventional 10 to 33 milliseconds, depending on the system. It's the accuracy that we can provide is basically state of the art. This is a structured light sensor at the end. So we provide the same, we have the same geometry constraints, and we have the same accuracy as a conventional structured light based on frame-based. However, the software complexity is basically reduced to the minimum, because we don't need to do, let's say, matching in post-processing. We can do matching inside the sensor. There is no motion blur because we can capture very fast the 3D point cloud, and we are also compatible with outdoor application. And the concept here is that we can go very fast with the pulses, so that we can increase the power of the laser pulse, but the energy, which is the product time and power, remains below the eye safety constraints. In the right, you see here 3 pictures to give you an example. Unfortunately, I couldn't upload video, but to give an example of what we can do. The first one, top left, is a face with a mask, because nowadays you have to wear mask. So you can appreciate all the details. The middle one on the right is a marble circuit. This actually is very interesting when you play live, because there are balls that moves at a certain speed, and you can see that we can track, we can have the 3D information of the balls without any kind of blur. And the bottom picture is not actually our output. This wants to show that the output of the sensor, say the structure light sensor, is compatible with industry standard. So the output ET is a standard 3D point of cloud. And here we basically use the Kinect Fusion to reconstruct the marble circuit plugged in let's say, onto our data. And as you can see, it works basically straightforward. Now, the advantages I commented a bit. I want to specify more. What we do, we project patterns like in structured light, but the patterns are not static in time, they are temporal patterns. So the dots or lines that we encode, basically, they encode their IDs in this temporal pattern. This allows us to recognize them directly inside the sensor. We can increase the robustness adding ECC, error correction code, because this is a code, so we can include also correction on that. The matching does not require geometry, because we know exactly which line IDs. We can think of strategy for doing auto calibration. And if we combine temporal pattern with fast camera, we can have very high refresh rate of the point of cloud, let's say more than 200 Hertz, just to give you a number. And if the camera is fast, but is also sparse, so this allows you to be, let's say, low power on computational requirements, but also on consumption. Now, the other thing is that the pulses that we are using are typically fast. So the duty cycle, let's say, of the laser, when the laser is on, is relatively low, which also allows us to be, let's say, to save power with respect to other systems. So this is in a nutshell the concept behind the event-based structured light. Why we are here? We are here because our expertise is in the design of the sensor and in the algorithm that goes with the sensor. We are not VCSEL projector makers, and basically we are looking for partners to make this VCSEL, which is part of structured light solution. And since we provide 3D point of cloud, we are also looking for 3D point of cloud users. So companies that consumes 3D point of clouds and then provide solution to final customers. And with this, that's it from my side. I'm open for questions.
Thank you so much for this great talk. And you got how it works with EPIC. You present what is challenging to the audience, and this is very important for us. So it's lasers and 3D points detectors. So do we have questions from the audience? I think. Okay, so how do you see the collaboration with the EPIC members or the people present here? Who would you like to be introduced to, or what company would you see the possible collaborations with?
So I must say, I don't know all the companies. Few of them I do recognize because they were also in the VCSEL webinar. And we are currently in contact with few of them because we are actively looking for a partner for VCSELs. And then I want to see the other presentations to see, to check if there are, let's say, users of this 3D point of cloud, because I'm not familiar with all the companies connected.
Simone, you're in luck because I know all of them. They do, and they are all fantastic. They are really all fantastic. There's a company that makes time-of-flight cameras. And it's a company, Maxi, the CEO, but he was very busy, and he told me, Greg is the guy who is going to represent Teravi today in the meeting. Greg, thank you very much for joining today. It's great to have Teravi here. As you know, I really look up to what you are doing. I think not everyone in the room knows Teravi. Could you tell us in a nutshell what Teravi does?
Yeah, of course I can, Jose. Thanks for the introduction. So Teravi specializes in optical time of flight. We actually work on other technologies as well, but that's our core expertise. We essentially build sensor modules. So we take available technology that's on the market and we build modules to a very high performance and sell those into lots of different industries.
If you could specify, because here we have companies who make optics, here have companies who make LiDAR solutions like Beamagine, who make smart glasses, companies who make integration of VCSELs into photonic circuits. If you could specify a couple of challenges that TeraB has today.
Well, a classic one, I guess, is outdoor operating conditions. That's always challenging. So technology that works well outdoors is something that we try to find. Other challenges is really just creating applications for customers and adding intelligence on top of the sensing technology.
I'm going to introduce you to one more company I want you to meet, because I live in the Netherlands and I love Dutch companies, but I especially love the guy who I'm going to introduce now, Jeroen. Thank you very much for being with us. Goedemiddag.
Hello.
What is NTS Optel and what are you doing in a meeting on structured light, in time of flight, in LiDAR? What are you doing in this business?
Yeah, thank you for this introduction. My name is Jeroen Sprankenis. I work at the very nice company NTS Optel. We are the optical group of the NTS organization. And we are really active in 3D sensing. So what we do is we provide high volume testing and inspection solutions to inspect so-called diffractive optical elements and multi-lens arrays. It's very important for eye safety. So when you have 3D sensing application, you do have a VCSEL, for example, 940 nanometers, and you have a DOE from that of an MLA, and then you project 30,000 dots. And all those dots has to be tested and on eye safety, for example, on quality. So we help on that point of view. We help big companies in high volume solutions. So yeah, our solutions are I think 80% of all the phones who are at the moment in the market are inspected by part of our systems. So I think that's very interesting. And also on LiDAR, we are active in LiDAR. We do a lot of demonstrating developments for LiDAR applications. So also companies can go to us to find help in optical engineering and optical solutions in our high-tech facility. Just finished that in the Netherlands, and Jose will join us and we'll look at it later on.
In 2 weeks, I'm going to go there. And of course, Jeroen, I need to introduce you to Greg, because obviously there is something that you can do together. Yes. Simone, about your VCSEL. I love VCSELs. As you could see in the previous meeting, I'm in love with VCSELs. Could you specify a bit the VCSEL that you're looking for in terms of wavelength or maybe power?
Yes, wavelength is 940 nanometer, because we want to use it outdoor. Power, I cannot comment. I'm sorry about that. We're not looking at 100 watt of power, obviously.
Okay, and is there any kind of packaging that you need in terms of optics, in terms of shaping of the light, or keeping them coherent for a long distance?
No, not on that. We don't have specific, let's say, different requirement than other application for that. Obviously, we're looking for the full system. I mean, not only the VCSEL array per se, but also the optic and the DOE. Yes.
Oh my God, you're going to get a lot of introductions, because I already get people telling me, introduce me to Simone from PROPHESEE. I also want to meet my new friend, Julia. Julia, thank you very much for joining this beautiful afternoon. I would like you to introduce yourself. I had the pleasure of getting to know you over the last 24 hours, and I would like the rest of us to share that pleasure.
Thank you very much for this invitation. That was very spontaneous. I joined Intel very recently. That's why Jose reached out to me as still an ETH member. I was at the Institute of Neuroinformatics a year ago, and I guess we met at the CVPR workshop on event-based vision. I worked in neuromorphic computing for many years. So it's answering the question, if we have these neuromorphic sensors, they output events instead of images, how do we process them? So we work on the processing computing side, developing algorithms that match this type of data, and also developing hardware that matches this type of data. And the group that I've joined at Intel is Neuromorphic Computing Lab, that recently developed a prototype computing device that allows to accelerate processing in spiking neuronal networks, event-based networks, which are particularly well suited for event-based sensing, but also for other sensing technologies. Right, that's the history of me being here.
Fantastic, and of course you are more on the software side. But when it comes to all these companies who are making camera solutions, is there any collaboration, any kind of potential overlap that we could have with them?
So my personal responsibility is indeed algorithms and applications. So looking into where to apply this technology in the whole system. Looking, in the robotics, IoT, sensing is definitely an important topic. So I'm sure that there could be long-term collaborations.
Because when I went to Paris, Julia, I went to Paris and I saw PROPHESEE's demonstrator. They asked me to sign an NDA, so I cannot tell you what I saw, but my eyes were, wow. You have seen what they can do. Is there any potential application field that you say, okay, I need to do something with these guys?
So I think it's a very kind of fundamental question. We know that the data that the camera output matches the type of processing that our neuromorphic computing devices offer. So my big vision is to cast most of what we do in computer vision in terms of AI workloads like object recognition, but also estimation of self-motion, estimation of depth, as Simone has shown. So all these workloads, put them in neuromorphic algorithms. So in these spiky neural networks architectures, which will allow us to make them run in low power budget and small size devices really efficiently. That's the vision. And application domains are vast, right? Everywhere where you need sensing.
I think obviously I had to make an introduction between the two of you. I think Ralf has a comment. We are talking about using technology outdoors. Is there anything INOPTEC can help these companies with?
Yeah, goedemiddag from my side.
Goedemiddag.
Yeah, I just want to mention, in case anybody needs contrast enhancement, we have developed something and patented something which is very similar to what you all know, which is a strobe lamp. A strobe lamp can make up to 100 pulses per second. And if you synchronize these strobes with a camera, then of course you can see against the sun, etc. So we took this established technology to the next level, which means our pulses are not coming in a harmonious way. They are actually coming in a way you can choose. So can I just quickly 1 minute share this screen so that you know? Of course. So that you know what we are talking about. Can you?
Crystal clear.
So let's see. Here we go. Is that working?
Yes.
Ah, it's working. Okay, sorry. Okay, so normally with a pulsed lamp, you have always the same pulse. And here below, in the lower part of this sheet, you see that the pulse width can be variable and the pulse height can be variable. And we developed a certain laser driver or LED driver, which enables that we put always the same energy into each pulse. So each pulse is, for example, 1 joule. So the first one is 1 joule, the second one is 1 joule, the third one, and so on. And due to the pulse width modulation, we can apply a voltage to a neutral density filter. You know this from photography. And this neutral density filter has a variable transmission, and you can put it in front of your camera. And then if the camera is in sync with the lamp, we can ensure always the same contrast. And this is very good if you want to see anything outdoors against the sun. So I don't want to go too deep into this. I just want to mention that we are here, and if Jose wants to make the connection, I'm happy to tell more. But in a nutshell, we can suppress 95% of the sunlight, and therefore it's a true signal-noise ratio improvement. This is all what I wanted to contribute for the moment.
Thank you very much, Ralf. No, there's a lot more you have to contribute. We just got started because now we are going to Florian and Eng, one of the most beautiful villages there is in the whole Europe, just next to the river Florian. I've been there because I visited EVG, one of the key companies you have in EPIC in the manufacturing of high-end micro-optics and semicon equipment. Thank you very, very much for being here with us, Martin. The floor and the attention of everyone here and in the YouTube universe is yours.
Hello, everybody. Hello, Jose. Thank you for the introduction. And actually, I'm today in a little bit different place in Austria. I'm in the famous Wachau region, but however, I'm happy to join the meeting today. And today I want to share a little bit what we are doing in this optics manufacturing for this advanced optical modules. Overall, just to briefly introduce EVG. EVG is equipment supplier for the semiconductor industry, very famous for MEMS, but also for nanotechnology, and nowadays also for photonic applications. This year is 40 years anniversary, and there is also a second thing to celebrate. We also welcomed our 1000th employee this year. As mentioned, headquarters is in Austria. However, we have subsidiaries worldwide. And just to give a brief overview, what happened recently on the equipment side, we further developed our Gemini systems for the hybrid bonding, stacking of CMOS image sensor, its photonic, laser debonding, another photonic topic. The bond scale fusion bonding, that's rather front end of line, but new ICs will be enabled by this. Maskless exposure, new digital lithography, and then our Hercules system, which is then for the nano imprinting, which I will focus today a bit more. Looking at the 3D and depth sensing, so I want to focus today as well here just on a part. On the right-hand side, there is all the sensing side. I would like to rather focus on the VCSEL modules, the projectors, and here for the structured light, but also for the time of flight. It's a very typical setup is you have a VCSEL array or single VCSEL in rather rare cases. You have some lens optics, and then you have diffractive optics or a diffuser or a micro lens array in some cases. And this is something we do actually quite a lot. So we are leading here, have a lot of install base to manufacture small scale, high volume VCSEL projectors. Overall, I had a brief look because this maybe many people know about us doing the wafer level optics and the stacking of these optics, including the nano imprinting. I checked what we have done actually already for such modules, and it's the nano imprinting of the beam splitters or diffusers, of course, a big portion of the lens molding of the micro optics, nano imprinting of polarizers on VCSELs, direct wafer bonding. It's a new topic for new ways for break mirror design, basically to enable here long wavelengths VCSEL with the new design. A lot of temporary bonding actually for wafer thinning to remove the heat. And also a rather new topic is the heterogeneous integration, collective die bonding, collective integration of laser dies onto surfaces or CMOS, well known from the silicon photonics, however, also considered to spread to other areas. Here for the lens molding, where I want to focus, and the nano imprinting today, basically it's a UV-based process. We use UV curing materials and a stamp, which has the actual shape of certain lenses or other optical components you want to make. And then we will imprint on top of the glass wafer. Of course, you can turn it and can make full modules. And as you can see on the left-hand side, basically it's a single system where we can mold and stack very densely hundreds and thousands of such lenses in parallel for a single module. And this all in very high quality. As you can see on the right-hand side here, an example, lenses we did in collaboration with Delo, close partners of us, which have very nice reflow stable materials. You can see here typical lenses with a height of 240 micrometer roughly. And yeah, this is basically for the module, but for the lenses, but however, for the micro lens stack, you might also need to come to the structured light, actual diffractive optics to have a beam splitter to get from one laser beam to multiple beams. And there are many designs known today. So basically the 2D structures, these quasi-random structures, multi-level structures, and also this newer type 2.5D structures. And with this nanostructured component, basically we use our SmartNIL technology. You can see here some references, what we have done. Even the stacking, I think it's hard to see, but the third picture you can see we have even high and low refractive index stacking of such devices to make even more efficient beam split. And of course, you can make here not only, you can also play around a little bit. We did the same. And we even did some nice holographic pattern here, seeing the solar system, which was done in collaboration with CNRC and IMS chips to make a nice demonstrator. That's basically it. So EVG for these VCSEL modules, especially on the optics side. So we can do here anything from the lens molding to make really very small form factor, high performance modules. We can implement the structured light, diffractive optics, but also micro lens arrays. And we can also go for, with the smart, and also for pattern transfer and transferring nanostructures if required. That's it. So you heard we are equipment supplier, semiconductor manufacturing. We have a broad range of processes. However, you don't need immediately to buy our systems. There are other ways to interact with us. We have our Knoll Photonics Competence Center, which is widely used to develop such high-end products, to run it up to pilot line and have fast time to market, that you can really bridge the gap between an idea you have just in R&D and ramp it really to the high volume, even up to smartphone levels. Thank you. That's it.
Thank you so much, Martin, for this very nice introduction. But you know how it goes at EPIC, right? You tell us what you can do. What we need to know now, what can they do for you? What kind of collaboration are you looking for? What are you looking for?
Exactly. So I think I've shown what we can do. What we always want to see, obviously, is people who come with their new ideas to us, but also within the supply chain. It's always important to align here, to have these collaborations. What we've seen here with this nice holographic structures, master suppliers, resist suppliers. These are things, but also coatings, optical coatings. These are things that are required to really make them the full module. Of course, I've shown we have a lot of technologies in-house. However, it does not build the complete module.
This is nice. We will hear today from all of this, particularly the optical coating, and I see already a background of freeform optics. We will be hearing more about that. Let me please introduce you to Georg from Nanoscribe. How are you doing, Georg? You are muted. Yeah.
I'm here. I'm fine, and I'm doing well. Hello, Martin. Nice to see you again. Only
Hello,
online,
nice to see you.
everybody. Hello, nice to meet everybody. Yeah, we are already in contact, Sanja.
Okay.
We met,
I think
that was,
Photonics did his job.
Yeah, we met at Zeus. Hello, Wilfried.
Well,
there was a long discussion in the evening.
Wilfried, would you please introduce yourself and tell us what you do at SÜSS Micro Optics?
Yeah, so my name is Wilfried Knoll, SÜSS Micro Optics. We also, of course, design nano optics, micro optics, structured illumination. We can design it, we can manufacture it. We have imprint here in house. And yes, we go a step further. We also do all the optical design, like I said. So we developed our own code for this, and we have a big team now. We have hired a few meta surface simulators, so we can do that all in house now. And then, of course, we're looking always for people to make masters for us. So there, some of them are in the room here, and this is always interesting for us to talk to these people. Thank you for introducing me, Sana.
Thank you so much. I'm very happy also that we have Carl Zeiss today with us in the room. Norbert, how are you doing? And how do you find the meeting so far?
It's really great. Thank you very much. I really enjoy also the format. It's really great to see you all and be new channel. So yeah, Edo Optics, and I'm from Corporate Research and Technology there, and we screen different technologies and also interested in computer vision and 3D imaging, of course. For industrial applications, automotive, LIDAR, these things are also interesting for us, and also in-house metrology. So many interesting talk up to now, and I'm looking forward for the next presentations, of course.
Okay, thank you very much for joining the meeting. And just to keep introducing everybody working on micro optics now, let's introduce Dirk, who will be a speaker later. But anyway, we should say hi. How are you doing from LIMO?
Hello, I'm fine, thank you.
Thank you for joining us. We will hear all what you do in a minute. Jose, do you have any questions?
Yeah, no, I want to say that you introduce anybody in micro-optics in the room. Micro-optics is really booming. It's really booming right now in Europe. I have never seen anything as big since the beginning of gallium nitride in Europe. I have never seen anything as big as the European industry working together to develop new solutions. I see companies active in the automotive, developing the carpet. I think the carpet for the BMW. I cannot say who is doing it, but there's a company in Switzerland, in Neuchâtel, who is doing that. But my question here is for the four of you, and I'm going to start with Wilfred. When it comes to high-end cameras, high-end camera solutions, we have been told about time of flight. We have been told about neuromorphic. Is it clear to you what are the key challenges for the high-end optics?
Oh yes, this is very clear. So these high-end cameras require very, very precise optics. Imprinted, so this is it's actually very difficult to do this by imprint technology. And I honestly only know of 1 or 2 companies in the world who may be able to do that, but and it's very difficult to get the surface profile right in imprint when you have a multi-level optical wafer level optics. So this is not at all trivial. So for diffusers and structure simulation DOEs, it's all straightforward. But when you have these stacks of lenses, to do this with imprint is extremely difficult.
Because Martin, you've been working with many companies in the light guiding business, in the AR segment. I don't know if I can tell you, I can say that the main customer, but maybe you can say yourself. Is it clear to you? Is there anything that we need to ask these key companies today that we have in the endomorphic solution, what they need from the micro-optics community?
So I think also we have a very well understanding here what's required, and we see also the precision upcoming, and I think we have taken it already, the steps that are necessary. What we rather need is basically to engage here with the people, with the designers, also to discuss what are the limits where they want to go for, because you can do a lot of things. We have proven this. However, to really ramp it to high volume, we also have to define a proper process window and define a clear path forward to have it in high volumes. It's not only precision on one module, it's precisions on millions of modules.
Exactly. That's exactly what you wanted you to say, the word high volume, because I'm going to go now to Jenna. I'm going to go to Simon. Simon is here representing Jabil Optics. Is one of the key companies that we have to scale up the production. We have 2-photon polymerization from nanoscribe. We have replication from SUS Micro-Optics and EVG. We have high-end micro-optics from different manufacturing technologies from LIMO. Is there a clear roadmap to take all these technologies to the volume production through Jabil?
So, Jose, believe it or not, based on the last seminars, I already made contact to the companies you just said. So I cannot give a definite answer, but those are relevant players in that market, and we are thoroughly evaluating.
So Jabil Optics is actually, I went to visit you in the location in Jena, and I saw that you are the manufacturers of the GoPro camera. So you have a long-term record on taking high-end optics to the consumer and high-volume markets. Today we are talking about neuromorphic camera. We're talking about structured light. We're talking about computer vision. We're talking about time of flight. Is it clear to you what are really the unique selling points of this technology and how to take this to volume production?
Well, for us, the application counts is not so much the technology. Technology is an enabler for the application. And there are applications in both automotive, in consumer applications, medical. So there's a lot going on. The question is what materializes fastest.
One company that you may not know, and I have met very recently, and I was quite amazed, is the company Luminit. And I have Suleyman here. He's going to give a presentation later. But Suleyman has been working on guiding light for different applications, including LIDAR. When it comes to volume production, Suleyman, is the roadmap, is the supply chain ready for taking this technology to the high volume production?
Certainly, I think there's a lot of capacity for a roll-to-roll thin film production of micro-optics on polymers. There's injection molding techniques as well. That's a high volume process. In addition, there's lots of wafer level, as other participants indicated, there's lots of wafer level production capabilities that, of course, is also high volume. It's a semiconductor process. So that supply chain is quite ready.
You're going to see how we are going to bring everything together with the next presentation. The whole round had a point. We have one of the key giants in this segment. We have Viavi with us. And Viavi is really the key component manufacturer from optics to filters and even some instruments manufacturing. It's a giant. It's a giant company, and we're so happy that they are a member of EPIC. Thank you very much for being with us, Georg. The floor and the attention of this very, very fun community is yours.
All the way from the US. It's not even 7.
Thank you very much, Jose and everyone. Let's see, full screen. Okay, can you see my slides?
Yes.
Okay, so I'm Georg Ockenfuss. I'm with Viavi Solutions. I'm in the part of the Optical Security and Performance Products Group. I'm the Director of Field Application Engineering, and I will tell you a little bit about Viavi Solutions. Most of you probably remember some of those names here. We are over 70 years old, founded in 1948. We're ARCLI or OCLI for a long time, got acquired in 2000 by JDS Uniphase because of our WDM filter technology, and then later split off into Viavi and Lumentum. And 2 years ago, we actually acquired RPC Photonics, so Rochester Photonics, who makes engineered diffusers. So we're going to concentrate here on one market segment, consumer electronics, and it's also related to automotive. It's a 3D sensing part of our business, where we provide a lot of optical filters, and I will explain the advantages of our technology in a minute. We supply to many tier 1 customers worldwide, and I think we are in this market one of the biggest component of filter suppliers. We do other filters for other optical sensors like ambient light, RGB, UV, near-infrared, proximity sensor, and also have now a new technology for multispectral sensing for color measurements and spectroscopy. So what's the specific about our technology? If you're a little bit familiar with standard interference filter, they have that nasty property that they shift towards the blue if you increase the angle of incidence. So on the over here, you have a brief sketch what kind of a 3D sensing system looks like. You have a near-infrared light source, which illuminates a scene, and then on the other side you have a detector. Now, if you want to go outside into ambient light or sunlight, as we heard earlier already, the problem is that the sensor sees all that light, which needs to be blocked to increase the signal-to-noise ratio. Now, if you have a filter, which if you want to have a large field of view, you have to make that filter much wider than needed to cover to capture all the light coming back from your laser source, which is indicated in this purple section here, and because of the angle shift. So we developed a technology which reduces this angle shift significantly, so you can make that filter much narrower, so you can block more ambient light. So it gives you a reduced bandwidth, enables larger field of view. In case of LiDAR or other systems, you can now look further out, and for consumer electronic applications, you can save more power. And at the end, it's all the game about signal-to-noise ratio, as we heard before. To make those filters, we have a very unique coding equipment, which was developed in-house, which allows high transmission, actually very, very good surface quality, which becomes very important if you want to put that filter very close to the sensor. We achieve very good blocking all over the whole spectral range, typically the silicon spectral range. And this coding platform allows us very, very good spectral placement. We can make filters from the UV 220 nanometers up to 5 microns in this platform. We have other technology which actually enables us to cover wavelength ranges up to 20 microns. And we also do polarization controlled coatings with this equipment. Now, switching gears, going from the sensor side to the illumination side, our partner in Rochester, they make these engineered diffusers. And on the left side, you see kind of an example where we can actually direct the light in a controlled fashion onto a screen or onto a scene and back to the detector. These diffusers go typically direct in front of a VCSEL or VCSEL array. And on the right side, you see what the intensity pattern looks like at the diffuser and what kind of irradiance pattern that will create at the detector side. So you will get a really nice uniform illumination at the detector. And with this technology allows actually to a certain extent also to create dot projections. So we are in the process of developing that. This technology is done with grayscale photolithography, where we create masters, and then we use a kind of a molding imprint process to create the diffusers. They are reflow resistant, and we developed or we deployed a lot of those into the consumer electronic market. At the end, we have 4 manufacturing sites, 2 in the US, Rochester and Santa Rosa. And for high volume production, we have 2 sites in China, 1 in Beijing and 1 in Suzhou. Okay, I think I'm open for questions. Thank you.
Thank you so much. So let me tell you how we do it at EPIC. You tell us what you can do, and you want to hear from you. What is it that you're looking for, or what collaborations are you open for?
What we are typically looking for, we are working a lot with startups and kind of R&D centers of larger consumer companies and also automotive companies to come up, kind of understand the problems of our customers and try to come up with distinct novel solutions. And I think that's one of our strengths. So all of the filters or diffusers, they are all customized to certain applications and requirements. So every customer has a slightly different lens design or optic design. So and we can help also the customers to come up with kind of cost-effective solutions for mass production and implementation.
So let me ask you a question. How hard is it to place coatings on freeform optics, for example, at the level of?
That's actually pretty hard. So that's not trivial at all. I mean, it depends on the material. So sometimes it's a polymer, which makes things even more difficult. So typically we try to stay away from that if possible. Our optical coatings are usually done on glass or silicon.
Mm-hmm. Let me introduce you to Savik. Hello.
Yes, hello, my name is Bernd from...
Would you like to introduce yourself? That's what you do.
Sure. Yes, my name is Bernd from SABIC, and we are a material supplier for optical thermoplastic resins. So our materials enable high volume injection molding or injection compression molding or film production of optical elements. And the advantage is to have really freeform lenses, for example, in injection molding, including diffractive optical elements. And you just mentioned that it's difficult to apply on a really freeform lens such kind of a filter.
Correct. I mean, it's the typically the problem is the aspect ratio and of the topography, which allows maybe a simple anti-reflection coating to put down on a structure like that. But thinking about doing a bandpass filter or something more complicated, this is very difficult, specifically with the technology we have. So we're using sputtering, pulse DC sputtering for our coatings. There might be something thinking about ALD, but I think that's usually done at a higher temperature, which kind of is not compatible with polymers. So it's a very, very difficult problem here.
Okay, how high do you go with your temperatures? What is the requirement?
That depends. Our standard deposition temperature is about 150 degrees C. We can go as low as 60 and still make really, really nice coatings. I mean, it has some impact on deposition time and stuff like that.
So we have thermoplastic materials up
we
to...
actually coated on your. We actually coated in the past on your material.
Okay, let's connect offline.
Okay, sounds good.
Yes,
Good.
Jose will do this, make it easy for you. And let me just give a word to Santiago from Beamagine. How hard is this for LiDAR systems?
How hard is
coating
micro-optics or coverings or filters?
Do you have any challenge, Santi? You develop Beamagine. It's a LiDAR company, very active, starting in the automotive, and you're looking at any other market and needs LiDAR. Is there any challenge that you have for the optics manufacturers in the room? We had the best optics that you can find in the world right now in front of you.
Essentially, what the main problem we face is, in our case, is to find out filters which are narrow enough, but which also accept large acceptance angles and still keep a low cost. That's our main worry regarding optics manufacturing. Another key issue that needs to be handled someday, it's not so close to optics, but it's closer to fabrication of micromirrors. We work with micromirrors. Micromirrors do have a problem with energy dissipation. So if you are scanning with a micromirror, then you have to limit the power that you are able to throw at the target, and then you have to manage a lot of energy with your mirror, and that's limiting you because you want to reach very, very far. So having some kind of micromirror recovery or heat dissipation sink or whatever that enables you to throw a lot of power onto a micromirror is something which is of real value. It's one of the limits that we are finding out now.
So what wavelengths are your systems working at?
Both 1 micron and 1.5.
Okay.
Very nice. Thank you so much. So again, Jose will make the introduction. Jose, please write your name in the chat channel. You can just send him an email and he will do all the introductions for you. Make it easy for you. Thank you so much again, Georg, for the talk. And the next talk is, as promised, from LIMO, from Dirk. Thank you for joining us again. And let's hear more about micro-optics from you. You just need to unmute.
Here we go.
Excellent.
So I just share on the screen.
Yes.
Okay, can you see it?
Not yet, but it's gonna come. So to share, you have the option at the bottom. Now it's working.
Okay.
So just have with the presentation mode and we're good to go. Very good.
Okay, so yeah, thank you for your introduction. And in the next minutes, I will introduce our way of structuring light and bringing light to the applications like computer vision, but also industrial applications and consumer applications. And our specialty is that we have optical technologies to control intensity distribution, angular distribution, not only in one plane, but also in three-dimensional structures. And we add another degree of freedom that we change also the intensity profile in the depth of field. So at the end, we have more or less a 4D beam shaping technology with our freeform micro-optics. And I will show you a little bit in the next slides how it looks like. for your orientation, maybe you know Focuslight, and LIMO is a part of Focuslight in the laser optic business unit. And we are focusing on the automotive and information technology. Today I will just focus on the LiDAR and machine vision applications. And in comparison to other structured light technologies that we've seen today, and maybe we will see today, of course, the key advantage is that we can bring a new dimension for human-machine interface to the industry and to consumer applications. And what we do in a different way from at least most of the companies in this field, that we combine refractive and diffractive optical features on the surfaces, and so that we can really design functional light distributions, not only in 2D but 3D, and we combine the 1D or 2D light pattern in a 3D environment, so that at the end the application runs with additional functionality. And of course, at the end we will just give you a summary for the community, the two questions. And concerning structured light, we maybe were not the first company that introduced solutions in this field, but we found that it makes sense to look more deeper into this technology. And therefore, we have here some examples. Everyone knows it started with some applications and with smartphones. But of course, it's important to measure geometries and distances, and maybe both together at the same time. You can see here there are so many possibilities in structuring light in case you can control the surface shape, the materials, or the combination of both in a very free selected way. The challenge is that every application has a different requirement, means different environment, different angular distribution, large angle, small angle. And of course, it's necessary to adapt the optics design, the refractive and diffractive optics design to fit to the application, but also to adapt the light source parameter to the application. And everyone knows here, of course, VCSEL laser, edge emitters, solid state lasers, or stacked emitters, all of them have different intensity distribution, different characteristics. And we have to bring the light to the application by changing the intensity distribution and making them compatible with the application. So that's the challenge of the structured light, to make use of the advantages in the application, but also to bring the light of the different sources to the right intensity, angular distribution, and structure geometry. And therefore, the hybrid optics means the refractive part of the shaping means to generate a certain field of illumination in combination with the diffractive part, gives you the possibility to bring the dot pattern to very large angles, for example. And this is possible that our models that we use in a computer, we start, of course, with a light source, but we can combine the diffraction part and the refraction part, and we can optimize the surface geometries in a way that both together can interact and bring you this nice pattern here that I've shown here on the green window here. But the key that it works is that we have a very accurate simulation and measurement technology, that we simulate the intensity distribution and we can measure it and compare it so that we have a good correlation at the end with our models in the computer and in production. And of course, and especially in our LiDAR application, it's very important to have a safe operation in low and high temperature, always without zero order peak. And therefore, you can see also the light that coming out of the laser sources are typically not symmetric. So that means we have some power going down, some power are parallel in critical areas. And therefore, it's necessary to shape the light and to pattern the light in all directions in a different way. And that's the challenge that only can be controlled in a good way with refractive and diffractive functionality on one surface. And the 4D beam shaping that I introduced in the beginning comes from the simple task that at the end, typically the customers want to have everything, right? They want to integrate into one surface all functionalities to make it simple and cost effective. And therefore, it's typical to start with a 2D intensity variation with dots or lines or stochastic pattern. But then to bring this pattern into the right distance in X, Y, and Z direction, you can see here, especially for these safety relevant applications, you have different distances where you should measure something, and you have different angles also where you have to control the light in a different way. And at the end, the task becomes very, very complex. And what you cannot see is the direction here in Y direction. Typically, we need a very large field of view, field of illumination, not only in LiDAR outside of the car, but also applications inside the car. So right now we work up to 160 degrees with such a optical element, with such a DOE, ROE design. And what we also introduce here is that we can do this even with off-axis illumination. Means that typically if you just look perpendicular and illuminate perpendicular to the surface, you get nice flat top. But if in case you rotate the detector or the illumination area, you get a non-symmetric intensity distribution. And this can be compensated with non-symmetric lenses like this elements here shown in the picture. And both together finally can compensate the off-axis illumination intensity drop that is described here together with this off-axis sun illumination. So you can see if you can control the surface of the lenses, finally you can really control the light precisely to many applications. And what we offer to the community, of course, we are a producer with more than 500 people in Germany, in China, with 3 production plants, and we make the design and simulation and production, including coatings on micro-optics on a wafer level up to 300 times 300 millimeter size. And right now we handle a level of more than 10 million pieces per year, of course, continuously increasing capacity. And we also integrated into laser sources, optics and lasers in one of these packages, for example, for time of flight sensors with structured light or with homogeneous intensity distribution. And what we offer as well, the ISO and IATF conformity in our production, and the IPMA project management, which is the key to organize all over the world projects with our customers. And of course, what the community can offer to us, of course, we love to make joint projects and to come on to solve joint challenges. And therefore, everyone is invited to work with us and to talk to us. And we learned that together we can achieve more than only alone. So teamwork is the key. So thank you.
Of course, it's the key. That I make a living out of that, and well, a totally crazy living, because I used to travel 200 days a year, never see my family, and now I've been here for 2 months, and they are so tired of me, you cannot even imagine. So I have so many potential partnerships, so many potential people that can do something to collaborate here. I'm going to introduce you to one friend I made during this online technology meeting. His name is Dirk de Man. He's based in the Netherlands like me, and it's a great country because we all love each other here, and we actually, our children are going to school now full time this week, so it's totally crazy. Everything is going back to normal. Dirk, LIMO, my friend Dirk, is also looking for collaboration, partnership. He wants to build a project. What does AAE can bring to the table here?
First of all, it's always good to work with a Dirk, because Dirks have one rule, and that's that Dirk is always right. So good to work with. Yeah. Looking at what we could offer to Dirk and to LIMO, but also to the community, is quite open, because we are very focused in developing new technologies that are at the point of breaking through. We've done that for 40 years, starting with the CD industry and later on with the start of the EUV. And right now we're at the starting point of helping OEMs and other companies within photonics. And I'm really anxious on being part of that and being part of a new revolution. So
this is the time of the meeting where I do my thing.
Yeah,
this is when I build a consortium. So I already have the company making the optics. I had the volume production, and now I'm gonna go to the company that makes the cameras from the time of flight. I'm gonna go to Teravi. I'm gonna go to Greg. I really love this guy. Greg, thank you very much for joining this afternoon. Teravi is looking at time of flight cameras. Could you tell us a couple of key applications that you are targeting with your different TOF cameras?
So in very simple terms, the most simple modules that we provide are single point distance sensors. That's anything where, distance and ranging is useful. And at the other end of the spectrum is 3D camera technology. And obviously the applications vary enormously. But one of the key things that we've applied our 3D time of flight cameras to is people counting. Particularly in these times of COVID, that's a very hot topic. And but we're also, looking at other applications as well. But that technology is proving to be very applicable to people counting. So the applications that we address are super broad, Jose. I mean, I could probably talk for an hour.
Oh, you could. I mean, it would be so exciting. And you just said people counting, and that sounded crazy. I mean, just before the whole world went completely nuts, you and me were in Barcelona at the, what was it, the one conference, I forgot, the cities conference. And,
yes, exactly.
And together we talk about putting the TOF cameras in a drone for different applications. What is normally the distance that you have in the people counting distance between the camera and the population?
So the maximum mounting height is about 3 meters. And that enables you to see a doorway of typically 2.5 to 3 meters, which is kind of, the standard sort of thing you might see if you enter into a supermarket. But we also addressing much, smaller passageways as well. So you can use the technology for, meeting room optimization and heating and ventilation and air conditioning optimization, for example.
And to illuminate the people, what kind of light source do you use? Do you use a VCSEL or use a laser or an LED?
No, it's near infrared LED. So that's what we're using currently.
And what kind of optics? Do you need to scan it or just illuminate the whole thing?
No, it's just illuminating the complete scene.
So you see what I'm doing here. So I already have the parameters, I have the light source, I have already the idea that we have to have a broad field of view. So then let's try to have an optics that we can put next to that LED. So we are talking about some kind of optics that can be a wafer level free-form optics. I'm going to go to Neuchâtel for now, and then I go to EVG. But first on Neuchâtel, you have been working with many companies who develop time-of-flight solutions. You were at a meeting talking about LIDAR solutions with micro-optics. What kind of optics do you think we can bring to the table? We are building a consortium here. We have LIMO, we have AE, we have Teravi. I want to bring SUS micro-optics as well.
Okay. So actually we're already doing stuff like this for sensing. We're already doing imprint solutions for certain sensors. I can't say more. And this is but not for people counting. That we're not in there yet. But for other optical sensors, we're already doing this by imprint, of course. And this is pretty cool stuff because it is high volume. It has to be extremely accurate because it's still kind of imaging optics, so it has to be very precise. And so it's challenging, but it works. So it's, thank you, Jose.
And now we're going to bring the next part of the puzzle. We're going to go to Optic Balcers, which is a company that develops coatings and filters. And I love these guys. I went to visit them already a couple of times. Thank you very much for being with us this afternoon. What do you bring to the table here? Can Optic Balcers bring the filter in the optics that we can put in the LIMO and SUS and manufacturing AAE to go to satisfy the need of Teravi?
Thank you, Jose, for handing the word over to me. As you mentioned, we are also a coating provider in the supply chain for structured light. We have solutions, particularly on the VCSEL, on the projector side, the micro-optics with lenses like Martin from EVG has shown before. So we have solutions for anti-reflective coatings, which are environmentally stable, can meet all the temperature and humidity testing. So that is not so straightforward to find working solutions, and we have done that for mass manufacturing for smartphone industries, and we are that's what we are looking at to look for other companies who are willing to go in mass manufacturing and apply coatings on such polymer lenses for millions and millions of lens elements.
So Julia, you see the kind of things we do here, right? Everybody brings something to the table and we try to collaborate, and it's so much fun to do it from my side. Actually, Ralf, I have a question from you from the YouTube universe. It's a person who didn't want to tell me in which company they work, but he asked me, he said, I have a question for INOPTEC. She said, could you suppress the light only in certain areas of the glasses? She's thinking about AR applications when virtual objects are too transparent because of incoming light.
No, we have just one big pixel, which is basically the glass. It's a shutter glass. And what we do is time domain multiplexing, or strictly speaking, demultiplexing. My background is telecommunications, and what you do on the receiver side, if you have many different information streams coming in through a single line, like a fiber optic cable, you have typically a demultiplexer at the end, so you can distinguish maybe 10 different channels. So what we build is basically a digital 10-channel demultiplexer with an analog pulse width modulation. Sounds very complicated. I can explain things later in detail, but in a nutshell, what we do is we change the tint of the glass very smooth, so without steps. It's a continuous grayscale due to the pulse width modulation of 2 to the power of 16 bits. And then we suppress, the other way around, sorry. We adapt automatically to the sunlight, so we measure the sunlight. And at the same time, if your augmented reality display is time-wise in sync with the open time slot of the shutter, then your light from the augmented reality display will go straight through the eye unhindered, whilst the sun gets blocked off at the same time. So in other words, we can distinguish between wanted light and unwanted light. And this is why we can enhance the signal noise ratio in a way that we ensure that the augmented reality display appears all the time with the same constant illumination, no matter how the background will change. So you could directly look into the sun, or you could look into the sky, or wherever. It will automatically adapt.
I have worked a demonstrator. Actually, it's quite fascinating how you can go from the indoor to the outdoor and don't notice the transition. It's quite an amazing job. Santiago from Beamagine and Greg from TeraV prepared to see something very special when it comes to light shaping for LiDAR applications. I just came across these guys, Luminit. Thank you very much, Suleyman, for being with us this beautiful afternoon. The floor and the attention of everyone goes to you. Your first ever epic presentation.
Thank you, Jose. Thank you. I love your energy. Thank you for the invitation again.
It's just about coffee. It's no secret here. It's a lot of coffee.
Yes. Same here. Can everybody see my screen at the moment?
Yes.
Okay, wonderful. So let me take it to presentation mode here. So I'm with Luminit. I've been with Luminit for 14 years and some months. And since then, we've really been working on LED applications. Back in 2006, we solved a number of general lighting applications with LEDs, with our diffusers. And lasers and VCSELs, in the meantime, have really taken a step up in adoption, gaining a lot of traction. And there are some challenges, definitely, especially in 3D sensing with working with those light sources. And I'm going to talk about that here. Just some background on Luminit. We were founded in 2006, and since then we've been focused on being a global provider of innovative light solutions for a number of industries: lighting, display, automotive, and other high technology industries. That's just a big bucket for everything else, mainly machine vision, biomedical, and of course 3D sensing. Our core expertise still is holographic recording of microstructures that are refractive and diffractive, and also the high volume manufacturing or replication of those micro and nanostructures. We also manufacture some holographic optical elements. These are diffractive elements. These are in the volume of a photopolymer. And since 2006, we've generated over 120 million in revenue since 2006. So we're not really qualified as a startup. We've been operating for quite a while now. These are some examples. Our light shaping diffuser is a pseudo-random microstructure on the order of about 10 to 80 microns in size. And then we've got micro prismatic structures as well, linear prismatics that we manufacture. These are computer generated holograms. And then micro lens arrays. We've recently acquired a Heidelberg direct write lithography system. So we can individually write each micro lens at a time now. And then we're also, our HOE is integrated in probably the most wearable and stylish AR glasses out there, and that's the Focals by North. I wanted to play this video just to demonstrate. Let me see. Let's see how I can share this. Can you see the video?
No, we cannot see the video right now.
Okay, let me see here.
Are you trying to share the video in your screen?
Yeah, here, I'm going to switch over to it here. Maybe this will work.
Now it works.
Okay,
very good.
So this demonstrates some of the capabilities of light shaping that we have. We can turn a beam, increase the beam angle of it. It acts as a negative lens. We can increase the beam angle in only one axis, and it becomes what we call an extreme elliptical line generator, basically. We can incorporate prismatic structures to turn the beam off axis. And we can combine those diffusers with prismatics to get a number of different effects. Let me go back to my presentation here. So I just want to review some of the requirements that we're seeing from the 3D sensing industry, and mainly on the illumination side again. So beam shaping is important when you have a very collimated or very small divergent laser beam. It's circular or elliptical. The requirement though is for the light pattern to be shaped into a special shape that makes the optical system more efficient. And those come in a variety of different requirements. Square is very popular, rectangular as well, circular as well. And as I indicated, elliptical, this is a extreme elliptical diffuser that we manufacture. It's a 90 by 1 degree diffuser, 90 degrees in one direction and 1 degree in the other. So you can turn a laser beam into a light line. And then also, of course, point clouds or random dot generators. These typically require diffractive optical elements to achieve that beam shape intensity pattern. And then intensity profile too. So not only does the shape matter, but the intensity of the pattern too. So this is a Gaussian profile. Most applications require a flat top and or bat wing, depending on how you plot it. So bat wing in a polar plot ends up being a flat top and on a projected on a flat plane. Beam quality is also very, very important. Many micro lens arrays that are used to create certain beam shapes do a very good job in creating that shape. However, there are spatial non-uniformities in the beam due to the fact that you're working with a coherent light source, and the micro lens array is periodic. So the beam quality is definitely important, and diffusers are commonly used in conjunction with collimating lens structures, as well as other diffractive or refractive beam shapers. The other requirements of 3D sensing: thermal susceptibility, as well as laser damage threshold. So that puts a big requirement or challenge on the material systems that's used. So sometimes thin films can be used down to 50 microns. If the temperature requirements exceed 80 degrees Celsius, there are options like polymer on glass, and also injection molding it in a monolithic polycarbonate material system from, say, SABIC and others, for example. And in the injection molding process, you can't get down to 50 micron parts at the moment, but 300, 500 micron parts thickness there is a capability for that. Now, thinner is better in a lot of these applications. Of course, in consumer electronic face ID type applications, that's understandable. But even in LiDAR applications, thickness is a big constraint because they're trying to integrate these LiDAR modules more and more into existing spaces like headlights and rear tail lights. So even in the automotive applications, thicknesses are very, very important. Optical efficiency is also very critical. You don't want to have a lossy optic, mainly because there are several optics in the optical chain, and so the requirements usually are 90% or higher, and higher efficiencies can be achieved by AR coating, anti-reflection coating, both sides of the optic. And we have capability to AR coat both film, thin film, as well as polymer optics and glass optics. And the use cases for 3D sensing are very strong. As I indicated, LiDAR is a big use area. Facial and eye recognition, that's already been established. Robotic and machine vision, of course, for monitoring a process, as well as these automated robots that are being utilized in many of the warehouses now. Those typically use near infrared transmitters and map out the environment so that they don't go and bump into each other or the furniture. Spatial computing for augmented reality. That's a big area of growth right now, and so HoloLens 2 is probably the most advanced AR glass headset out there. It incorporates infrared transmitters for eye tracking, head tracking as well, and mapping out 3D mapping out the environment.
Thank you so much.
That's it. Sorry. Yeah. Do you have any questions?
Thank you so much for the very nice talk, and I really like how you can give eyes to robots. That's so cool. Let me start by asking you the classic EPIC question. So now you tell us what you can do, the very nice applications, and you want to know what is it that you're looking for, or what can they do for you?
Certainly. The challenges in all these industries are quite dynamic and constantly changing, of course. So we want to learn what those are and stay up to date on these challenges, so we can help find cost-effective and high-performance solutions for those industry members.
So you spoke about LiDARs, and that's why I would like to go back to Beamagine. Did he satisfy a little bit of your requirement from earlier?
I'm sorry, can you repeat that question?
My question is to Santiago from, yeah.
Well, I mean, beam shaping is something which can have very much relevance in some applications, but it's difficult to me to see. I mean, we can use the applications that you suggested just for trying to have better transmittance across the lenses that we are using. That's essentially the main point, I would say, at different, at all incidence levels, as far as I understand.
Yeah, same for TRB for Craig.
I had a feeling you were going to come to me and ask me that question. I have to say, very fascinating discussion, fascinating talk. I need to take it to our CTO actually, because that's his domain, and he follows new advances in technology very closely. So for sure, I will be making sure that he's aware of this after today's discussion. But as to whether I can say, it categorically solves any of the challenges that we're facing, not really my call. I would want to defer to our CTO for that one.
Yeah, people counting is definitely a hot area currently, even hotter with the current requirements in the States for keeping social distancing, especially in retail environments. So we're seeing a lot of interest in flood illumination of these retail environments, so that the sensors can count and determine the distance between people.
Yeah, I actually have the exact same question still to PROPHESEE. Simone from PROPHESEE. Okay. Oh, maybe while we're waiting for him, I would like to ask how is Julia finding the meeting so far from Intel? I have a question for you. Now we can do face recognition, and what other applications can be there? And what about security in all this?
Yeah, so I guess as you noticed, right? So we are more on the algorithm side and kind of what to do when information leaves the sensor, right? So you have the optics, and then you have the sensing technology, you have the whole system, and we are on this back end where we will now compute something with all that signals that come out of the sensor. And there the possibilities are well known, right? Particularly in the field of AI, it's from face recognition, people recognition, object recognition in general, and then estimation of parameters of objects. Now, if I want to estimate the size of the object before a robot can grasp it, localizing objects in the environment, solving SLAM for either robots or drones, all these smart, intelligent solutions. And of course, how well you can solve the task depends on your computing architecture, how fast and efficient it can run, but also on the quality of the sensor and the quality of information that you get out of sensor. For us, an interesting direction is active sensing. So how far back to the sensing technology can I go from my computing technology? Can I go all the way to, you know, optic and maybe kind of tune the direction in which I perceive? So that's one interesting question we have on the back of our minds. I guess this feedback between compute and sense.
This will be an extra load on the power consumption as well, which is a very critical point for this technology. All right. Simone, I think you're back.
Yeah, sorry.
Yeah, we can hear you.
Can you hear me?
Yes.
What was the question?
Oh no, I wanted to know your comment about the talk from Luminit, from Suleyman.
That was, let's say, very interesting. For us, it's a bit, let's say, far away, if you want, because, like I said, we are a design house or software house, depending on the point of view. So, let's say, all these things, typically we rely on other partners to do, let's say, the optics and the filters and the shaping. Requirement-wise, we may discuss.
Yeah, that's why you're all here today, so that there's always a room for a discussion between
Sana,
you all.
I am so happy right now because we have now Intel, PROPHESEE, and we have innovation in the room. Thank you, thank you, Kynan, very much for joining the meeting this afternoon. How are you doing today?
Good. Yeah, it's thanks for the last-minute invitation.
Yes, I'm sorry. We talked today, right? It was today when we managed to engage.
This morning. Yep.
Yes, this is all thanks to Julia. Julia is like the spider in the web that is connecting Epic to all these metamorphic cameras. Kynan, we talked in the beginning, we had the presentation from PROPHESEE. They were talking about the technology, the MetaVision sensor for different application segments. And Julia was talking to us about different application fields. Then we had a presentation from TeraV. They were talking about different applications. They talk about people counting, for example. You're going to give a presentation later at the end, but could you tell us a bit about innovation and what kind of market segments, applications you want to cover?
Right. Yep. So I'll just give a short history. So we're a spin-off of the University of Zurich and ETH Zurich. Actually, I worked before in the same lab as Julia. That's how we know each other. We've been working on this neuromorphic event-based vision technology for over 20 years. It was incubating in the lab for a long time. And about 11 years ago, I tried to see, well, maybe someone wants to buy one of these. And so, I was still in the lab and we sold one camera and then two cameras. Initially, this was to universities, right? Other researchers who would then use it to write a paper or get a grant or something. And then over the years, we started getting interest. We did a project with IBM on their processor. Then interest came from car companies, then consumer electronics companies. And in 2015, I went full-time on this, and this sort of built up over the years. Last year, we did a licensing deal with Samsung. So now Samsung has the chips at mass production volume, and we're working with them on a couple of use cases. You can probably guess some of them.
Yeah.
And so yeah, I think we're just getting started. I think it should be the overall message.
Today, I'm going to introduce you to a lot of friends they have in front of you. But basically, the message is that in front of you, you have the companies who make, in my opinion, the best wafer level optics in the world. We have the companies who can actually make wafer level testing. We have companies who have been developing LIDAR solutions for the automotive sector. And we have, of course, we have SAIS, we have AEE, we have a company, TeraV, who is in the time of flight. Is there any in the supply chain, or in the, I call it the Santa Claus Christmas list of components that would you be interested in asking Santa Claus?
Good question. You're really putting me on the spot here.
I love that.
So let's take the automotive thing as an example, right? We have a lot of interest from automotive companies for the technology. There are two things that are clear. First is that they're going to have custom sensors, right? We can't take the consumer mass production chip and just directly put it into a car, right? It won't meet, in particular, the temperature performance that's required. So this means, extra investment for automotive. And so we need to work with different suppliers who can help us get there, right, to the automotive grade performance. The second thing is that if you tell a car company that we are going to replace all of their cameras, they don't accept this, right? They've invested billions into their existing vision pipeline, and so what is clear is that our technology is a complement, right, to what's already been there. We handle certain edge cases which cannot be handled by existing cameras, and then over time, perhaps the number of cases that can be handled by the technology expands to cover more and more, to improve on what's already there, and improve power consumption, reduce the cost of compute, and so on. And so I think would be interesting for us is to really work with key suppliers on how we can integrate all of this into a single do everything chip, right? Some of our prototype chips do capture frames and events in parallel. They have, that I think this is what the car companies want. Single chip does everything. Frames, events, and then later on also high level features in their visual pipeline that they can use directly.
That's quite fascinating, actually. I've been working with many car makers in the last months. We actually have a meeting on the 15th of July about ADAS and autonomous driving, in which we're going to have, I think, around 15 car makers already confirmed. And the idea that is exactly on your line. They don't want to change us, the cameras, or even the architecture, or even the optics, and having the whole supply chain automotive qualified has been one of the challenges. And one of the companies in Switzerland, SUS Micro-Optics, actually has completely automotively qualified the process. So it's one of the companies who really we are engaging on this particular segment. But about adding functionality to a chip, prepare to see something very special. The next speaker comes from the Netherlands, the best country in Europe, maybe. Goedemiddag, Douwe. Douwe is actually representing the silicon nitride platform that is making a difference in photonic integrated circuits. But today he's in structured lighting because they can do something very special, adding functionality to a chip. Douwe, tell us about what you can do to scan light without moving elements. The floor and the attention of everyone goes to beautiful Enschede. Goes to you.
Thanks. Yes, indeed, beautiful. I needed to relocate both for the heat and as well as I'm standing to present this to get a bit of the energy that you have. I cannot do that sitting, and I cannot drink as much coffee as you do. So let me share my screen. Where's it? Right. So can you see my screen? Oh, now?
Yes, of course, crystal clear.
Right. Okay. So I'm from LioniX International, and we provide.
Could you go to presentation mode?
Yeah, I thought I did. I did not. Right. Okay. So I'm from LioniX International, and we provide customized microsystems solutions. That said, we target mainly on integrated photonics and customized MEMS. And we have a background also in fluidics and optofluidics. I will tell today mostly about the photonics part, since we are in an EPIC online technology meeting. So we do customized solutions, which means that we don't have our own products. We design for our customers there, which are typically the OEMs and system integrators. And we do that by vertical integration. We do it from the design to the device. So we are not a foundry. We can do the design, the manufacturing, as well as the assembly and packaging of these photonic integrated circuits into a module. And we can do that in scalable production volumes. Scalable in the sense that we do a lot of prototyping work and getting the crazy ideas out. But we can also grow with our customer into production volumes, and also into any volumes. That is what we want. We want to address the volumes which are associated with the telecommunication markets, but also we see good business in metrology, whereby you only have 100 or 1,000 pieces a year, and we want to address both. Furthermore, we have always been on the forefront of what's possible with silicon nitride, and we want to maintain that. So we do photonic integrated circuit modules. That's some pictures at the lower bottom there, which means that's a silicon nitride based photonic integrated circuit. A photonic integrated circuit, for the people who don't know that, I have learned that I cannot assume in a photonics world that people know what a waveguide is, right? So that's a chip that guides light like an optical fiber, but then with on a chip, and you're all users of it because you're using the internet at this moment. However, we have a different technology. We make it with silicon nitride. The advantage of silicon nitride that we call triplex is that it's a very low loss waveguide, so you don't lose photons, and it can operate from 400 nanometer up to 2350 nanometer of wavelength. So we can also use wavelengths outside of the standard telecommunication window. Furthermore, we have ways to optimize the mode sizes of our waveguide. So we can optimize, for example, to match it to an optical fiber, but we can also optimize it to match to a laser diode. And together with hybrid assembly there, we can assemble a semiconductor laser or VCSEL or LED to our silicon nitride platform. And we can do this waveguide tapering. You have also a low loss coupling of your laser source and into the silicon nitride chip. As said, a photonic integrated circuit is more than a chip. So the assembly and packaging is also much important because our customers cannot deal with the chip only, and we are not a foundry. We can also do assembly and packaging there. So what about structured light then? So on this chip, you can do all kinds of functionalities. So you can manipulate the light, as we say. You can play with the phase, you can split it, you can modulate it, you can switch it, and we can also do that for the visible light colors there. We have tuning mechanisms both in the thermal optic ways, but also in the stress optic ways that can manipulate the phase on the chip. And by doing that, you can make structured patterns, right? It is shown in the top right, in the green chip on the left makes the patterns on the right. Because we can split light and we can make multiple interferences, we can make these patterns there. But the nice thing about this is we can manipulate where the light goes, right? And therefore we can change this pattern. We can change it from this line pattern, which is a simple 2-dot interference pattern, into this more complex pattern, which is a interference pattern of a couple of spots in a circular fashion, right? We can do that because we can the spots can come out of the side of the chip, but also from the top of the chip, either with gratings or with mirrors, either micro machined or etched there. So that's this way you can create different kind of structures, and you can tune it. Right, so I was not allowed to have a movie here, so I don't have to actually show it there. But if you want, I can show you very nice movies of this light morphing structure of that. As said in the lower right, we can also integrate the laser source in it. Right, you see examples here of a flip chip VCSEL on top of the silicon nitride, which is coupling the light through a grating to the waveguides. And as well detector arrays if that's needed. In the middle part, you can see a semiconductor optical amplifier or a gain section, which is butt coupled to a silicon nitride chip, basically making a external cavity laser, which has a very narrow line width tunable laser. And one of the universities we work there with this concept there has the world record of line width there, in the order of 40 hertz, and it's still tunable, right? We can also do that wafer scale by etching holes within the wafer and then flip chipping such an SOA onto the silicon nitride chip to make it a wafer scale process there. So that's what we can do. What we ask for the EPIC community is we are not application specialists. So we know all about photonic integration. We know how to make it. We know how to produce it. But what can we do with it, right? So we can make very nice structures of it, and we would like you to really like to ask you what can you do with it, right? So we want to learn about the issues for many of the OEMs or system integrators who ran into issues with system size or your mode properties, that your system is not robust, or you need to integrate multiple functions on it, or that you generally need to manipulate the light there, right? And we want to hear the idea from the application developers in structured light, or structured light in metrology, or in optical phased arrays, microscopy in the AR/VR direction there, right? So some of the examples that we are working on at this moment is an RGB light engine for AR/VR, where red, green, and blue diodes are combined with the silicon nitride to a single spot. We have a visible light 680 narrow line with tunable laser demonstrated earlier this year, and we would love to hear your ideas there. Thank you.
Thank you very much for a great presentation. I was yesterday in Enschede. I was there. I was there. I am crazy. I'm everywhere. So I have to say that LioniX is the success story on vertical integration of photonic integrated circuits, and you have made a huge difference already in the areas of biosensor, in the area of 5G, in the areas of the telecom. They actually, whenever they need a supplier and it doesn't exist, they build a company, so they build fixed to package their own devices, and they also package other devices. So now you come to the structured lighting and you are asking people to help you with applications, to help you with challenges. So I think I have a couple of good people here to help you with challenges. I'm going to go first to my friend Julia, because I really like talking to you, and you are from the application sector. You have seen what they can do. Basically, what they can do is to actually pattern light into almost any shape without any moving parts, and actually even make it scannable, and they can use from visible wavelengths to infrared, even mid-infrared. Is there any track that comes to mind, any roadmap, any idea, any challenge, anybody that you think they should talk to?
Maybe one little step that this does sound like, as something that can be kind of active sensing direction, right? So something we could influence on the kind of optic side by this technology. The application is a different question, right? So there, I think I'm also going outside of my depth where this could be used for. But this, as you said, right, I think you have it all on your radar, right? AI, VR, metrology, all kind of, microscopy, or kind of seeing beyond what is obviously can be directly sensed, some kind of indirect sensing. That's all what I can add. So,
well, that's already very good. At the end of the day, it is clear that we have to think about outside the box here, and it is here that this is a completely new approach, but with huge potential, because I want to address there is absolutely no moving elements here. It's really a cheap silicon nitride chip produce a wafer level in the volume production is virtually costless. I'm going to go to my friend from SAIS, Norbert. Thank you very much for joining this afternoon. When it comes to SAIS, of course, you develop fantastic optics, perhaps one of the best in the world. I support 557 companies. I cannot say that SAIS are the best in the world, but perhaps they are. When it comes to metrology challenges, I know you have been working in the same building in Jena. You have MAR, they are great metrology company for optics. Is there challenges still on the metrology of high-end optics that the wavelength flexibility the LioniX technology has could perhaps help? And we are thinking out of the box here. We are not thinking specifications matching yet.
Wavelength is one point. However, it's integration and stability of the optics. I think this is the main issue, and therefore integration definitely helps. The more stable the optic is, the smaller and more compact it is, the more stable it could be. So therefore integration is therefore also a really important issue for us, and therefore we think also about integration of our sensors and multiple sensors, not just traditional optics, but also integration with sense, but it also becomes more stable. Therefore, wavelength, it depends on the application, what wavelength you choose. But this is also true for microscopy and other applications, where you, with integration, you have also the potential for scaling, and therefore also you can think about different applications there. Yeah. But if you ask about metrology, I think the most important thing is the stability regarding afterwards calibration, all that stuff. You want to be really precise.
Okay, and then I'm going to go to NTS Optel, because when it comes to helping companies in different applications, especially in face recognition, you have been setting up metrology tests for all these companies for the wafer optics. Is there any collaboration that comes to mind when you saw what LioniX can do, which is, in my opinion, is fascinating?
Yeah, I think it's very fascinating what Douwe, this company make. We know Douwe, of course. But he should visit us in our new building and discuss some things. I think I have two potential markets where I can introduce to him. I have to think about that. Yeah, let's see. I think it's a really new market potential with this technology, and I'm looking forward to discuss with Douwe further on and look for how we can cooperate on that, José.
I'm pretty sure there is something you can do together, and I look forward to go to see you at your new building at NTS Optel. And that way, I cannot tell you yet what I did in Enschede yesterday, but it was something very special. You're going to see it in the news very, very soon, and you're going to be amazed. And I'm going to go to another potential application of your technology. That way, we're going to go to LiDAR. We're going to go to LiDAR, and in the beginning it was for automotive, and they make a big presence in automotive, and now they're looking for other application fields. Santiago, all the way from beautiful Barcelona. Thank you very much for joining this meeting. Tell us about Beamagine, and most important, tell us how we can help Beamagine. The floor and the attention of everyone is para ti. Santi, I think we have you muted now. So we cannot hear you. Now it's okay. The floor is yours.
Okay. No, so I was saying that, as always, it's a pleasure to present for EPIC. I mean, we've had a lot of success stories in the past with EPIC, as you know. So coming to see and to show what we can do and seeing what we can find out afterwards is something which have worked a lot for us in the past. And that's something which we are able to I think, to recover, because at least I've seen one potential application today, which could be very, very interesting to explore, and we can see it later on. We were a LiDAR company, just a LiDAR company. We started as a LiDAR company, so essentially, sorry, I cannot. We were just, we got our own LiDAR technology 2 years, 3 years ago. We had the patents, we had an agreement with automotive, so we were able to develop it in extent. But the main point with our LiDAR is we are a long-range LiDAR, we are targeting long distances. And we got now a solid, of course, short distances is easier in that point. And we managed to have that with a solid-state LiDAR for automotive. MEMS mirror is solid state. We can discuss that if you wish, but they accepted that. And the nice thing of our technology was both the solid state and the large spatial resolution we have, which we can bring down to 0.5 degrees, which is having 400 points in the scene. The reference, now it's Velodyne is trying to develop something with 128 with moving elements. So, well, we are not so badly positioned, I believe. We've moved from automotive to space and to maritime, and well, we can have, I would suggest we cannot show videos here in practice in telcos. It's not the best thing, but if you go to Beamagine.com applications, you can have some of the videos that we are seeing and that we are doing. And essentially, we soon working in automotive noticed that there was a problem and they had to manage, which was that, of course, if you want the autonomous car to work, you need several sensors. That's obvious, because essentially you want to diversify failure modes. So if something works at night, it may not work in day, or conversely. That goes again for the measurement principle, and that goes for trying to make the good decision. Maybe you can have to choose between 3 sensors just because one of them says no and the other one says yes, and you have to decide whether to break or not. So you need a lot of redundancy and to have as much information as you can. So that's out of discussion. 5 or 4 types of sensors will be needed, but it happens that this comes with the pain of fusing the information, because when you got LiDARs, especially starting LiDARs, when you were rotating LiDARs and images, you had issues like these ones that you are seeing here. This is the overlap of a LiDAR in a video image, and you will see that when you are closer, you have one type of problems, and when you are far away, you have other types of problems because you are with different parallax problems. You got different distortions in both optics. You have different points of view, maybe, and you have even different fields of view that you can have to cover. And that means that when they had to try to train their artificial intelligence with this, they had a lot of pain. And we managed to find a solution with the technology that we had, which enabled to be very, very good, very fast, managing to have real-time data fusion free of parallax error. And I didn't point it out before, but I think it's something which makes us very special. It's the fact that we are able to do both the hardware and the software. So we build the LiDAR with our hands. We are able to specify and change whatever it's needed. And we are able to develop the software to make it work and to perform properly as a LiDAR and as data fusion. So we managed to mix 2D and 3Ds very, very seamlessly with data fusion. And then we had new processing capabilities because in one single point, we were able to mix the 3D information and the 2D information, which give us new opportunities. And of course, once you've done that with pixels and with RGB cameras, you just have to move a little bit forward, and you can do it with RGB, you can do it with near infrared, with shortwave infrared, with thermal, with polarimetric cameras. And I've seen today that maybe we can try to do that also with neuromorphic cameras, which was, I guess the working principle is just the same. So we can try to have the 3D information just overlapping in the neuromorphic camera. So we can maybe have ideas for new applications and for new concepts from this. Our latest unit is this thing that you have here. It's more or less looks like a microwave, but it's not the size of a microwave. It's just 10 centimeters by 20 by 20, more or less. And we are now doing the industrial version of that, and it's going to be about 1/3 each dimension. And we are able to fit in up to 12 different imaging modes, which are fused, which enables us to have a very, very strong sensing platform. The next, we can see some examples. This is 3D LiDAR combined with RGB. You can very seamlessly mix whatever you have, and you have the 3D information and navigate the point cloud with the color information on it, giving more data than you had previously. You can do that with polarimetric cameras, which is also something which is pretty much novel and not so much used, but which can be used for detecting things like objects in the middle of foliage, or a last application that we will see, objects in maritime environments are very much beneficial for these kind of systems. You can also do that with thermal cameras, so you can have the 3D information and detecting something in the dark, typically someone in the dark, combined with your LiDAR. That's very much interesting. We've discovered for the security market, and that's something we are exploring now with a partner in Korea. And essentially, you could also mix all the modes between them, so you got up to 12. That's the main idea I would like to admit. And the nice thing is that we do the hardware and do the software. So we are able to tune the system according to any specification. We can change spatial resolution for space. For instance, they ask us to have very slow frame rate, instead to have very much larger spatial resolution. And of course, we can switch between up to 12 imaging modes or different types of cameras, which can be, depending on the application, RGB, near infrared, shortwave infrared, polarimetric and thermal normally, and I don't know, maybe neuromorphic in the near future. This is a typical use case that we've discovered it's very relevant. It's a man-to-water case, and that's something there's a video in the webpage, so you can check that, or ask for it, and I will send it to you. That's a test of what happens when you make the image of somebody on the water with LiDAR and polarimetric camera. The left side is LiDAR fused with polarimetric information. The right side is just the polarimetric information. Of course, with the polarimetric information, you are able to know just the scene. It may work much worse in nighttime than in daytime. But if you are in nighttime with a LiDAR and the polarimetric, and with the LiDAR, you can find the guy. And in the daytime, you know where the guy is in 3D. So it has a lot of potential applications in people falling down from cruises or from this kind of fisher vessels, things like that. That's something we are working on currently. And as last slide, as far as we've been in the past year in different EPIC meetings, what I've discovered is relevant to us for is what you look for. So what we are looking is for integrators and end users in security and automotive vehicle markets, people working as integrators in industrial vision robotics applications, and also distributors for joint business plan development in given applications. And the other point we've been strong in the past is for users of artificial intelligence algorithms, where they do multiple sources and they need data collection units, which are efficient and which give the data collection altogether. And of course, we come from research. We are able to do the thing from upside down. So if you have a nearly impossible use case that you are interested in trying to develop jointly, that's where we are, and that's a pleasure for us to jointly try to develop with you. So that's essentially what I wanted to say. We'll be in some trade fairs this year. So if you come by, don't hesitate to pass and have some cheers. Thank you very much.
Thank you so much, Santiago. That was excellent. And thank you for being open to collaborations as well. And there's a lot of people I would like to hear from their feedback after hearing your wish list. Let me start with Teravi. I think you are expecting me, right?
Yeah, yes. I am. I'm getting to understand how this meeting works now. So yeah, very interesting, fascinating. Actually, I was at the IFSEC event the last time it ran in London, which is a big security event in the UK. And I could see that LIDAR was just in its infancy in that market. But I spoke to a few people, and I guess there's a possibility if it can achieve the right price point, that it could be the next big wave in security. So it's quite interesting. From my own sort of personal point of view, a lot of what Terabi is doing in terms of applications don't tend to be that very long range, very high definition, sort of outdoor type applications. But at the same time, you know, we're always interested in new technology. I mentioned at the beginning of today's meeting that you know, one of the challenges we face is applications in outdoor environments, particularly when you've got a lot of bright sunshine. And we're looking, you know, we're always interested in technologies that would enable us to address applications in that environment. So it's definitely interesting. I'd like to understand more. I think, you know, offline we could have a discussion about, you know, where this fits in the marketplace against all of the other LIDAR type of solutions that are out there, and you know, and its pricing and all of these kind of things. So yeah, interesting.
Excellent.
Thank you.
Excellent.
Thank you very much. Thank you.
Excellent. And Jose will be there to help you with all the introductions for all the wish list you gave us, which is amazing. I would like to also hear from Dirk. LIMO, you're expecting me, right? As well.
Of course. Yeah, it was very interesting, good overview and interesting technologies that I've seen there. And it seems to me that maybe we can come together in case we want to integrate it into more compact industrial automotive capable format. And that's something that is maybe an interesting overlapping area that we should talk about later on.
I agree. That there are some things that in special things like tailored optics or tailored phaser. I mean that diffractive optics combined with optical ratings can have a lot of sense in given points of the design that we currently have.
Okay. Yeah. Great.
You have a lot of work, Jose. There is something shaping up, and now actually we can add to it from Jabil. Simone. You are muted.
Yes, I kind of have the same impression that making it suitable for automotive applications, it needs to be smaller in form factor. So that's something that Jabil could look into from an engineering point of view, but also if you want to ramp into higher volumes in automotive grade or other applications, that we should be the right partner.
I agree. We're moving on that point, and that's when the final architecture is finally fixed for automotive. I'm sure we have to move into that direction.
Okay, thank you so much, everybody. If there is no more questions, then we can move to Kynan. We are so happy to have you here and looking forward to hear your talk. Now everybody will be looking forward to it. So please share your, we can see you sharing your screen. Perfect.
Okay, great. Yep. Thanks a lot for the last minute invitation. Very happy to be here. Yes, so we do, neuromorphic vision systems.
Would you like to put the presentation mode, please? Sorry for that.
Actually, I've never done this.
Okay, that's it.
Is that working?
Yeah, if you just push yeah, perfect. Thank you.
Okay. And so we're aiming for order of magnitude improvements in response time and efficiency, right, for a whole range of different applications. I think probably our colleagues at PROPHESEE have outlined the general approach to the technology in a previous talk, I'm guessing. So I'll be very quick here, right? So we're not doing traditional frame-by-frame output. Instead, every pixel is operating asynchronously and outputting only log intensity changes at individual pixel level. So in this little picture here, you can see Toby, who's the inventor of the sensor, playing tennis, and the green pixels are the ones where the intensity has increased during the last frame. This sensor actually does frames and events in parallel, and the red pixels are where the brightness has decreased. All right, so as I mentioned, you get a lot of improvements in the latency. It's very fast, sub-millisecond latency. It's very high dynamic range because of the log intensity output. And the amount of compute with the right algorithms, which is the tricky bit, can lead to very high efficiency gains. And so to help explore this space of applications, because obviously it's very large, what we did was we started selling development kits, right? Initially it was universities, and now it's a lot of companies in all sorts of different application areas. So we provide these reference cameras, which are basically like industrial cameras. We can provide the modules and also the sensors at volume with our partnership with Samsung, as I mentioned. We provide an open source development platform, which enables you to create modules. So we provide some modules, of course, to do the camera interfacing, to do different levels of processing like noise filtering, calibration, and so on. And you can basically use our API to build your own modules, connect one module to another module. You can pass events between the blocks, or you can pass frames. You can even pass other data types, such as IMU data between these modules. And so it's really a rapid development environment. We're trying to get as many people building as many different applications as we can. And we also work with different customers on specific modules to achieve higher level functionality. And this framework is designed so that you can develop using this GUI, but the engine underneath is completely independent. So when you're ready to deploy on your target system, you just take away the GUI and the engine itself runs, and you can connect to it remotely for debugging and diagnostics and so on. We've sold this to over 300 customers in all of the all over the world. This map's not up to date, but we've had quite some success in getting penetration into the market. And from this, we're distilling this now into a number of use cases. Now, in this talk, I'm only going to talk about structured lighting, right? And there have been two developments that I'm going to mention today. The first one was actually originally a university development. This was Northwestern University. So they combined one of our sensors. This is actually an old, very old one, a 128 by 128 pixel. And this is a pico projector, so a very small DLP projector. And they basically hacked it up. And the idea is to project single points very fast and then pick up which pixels were activated and then triangulate position. And so they showed that it was possible to do this in a quite compelling kind of way. So they compared this quite low resolution sensor with the Connect and showed that you can actually get quite good 3D reconstruction. This was another test. They also showed that because of the high dynamic range of the sensor, you're able to get 3D information in lighting situations where it's otherwise not possible. It's also much faster, again, in comparison with the Connect as their benchmark. And you can do, quite impressive things considering that this was a very low resolution sensor at the time. So I think this is sort of one area in structured lighting which has a lot of potential for the future. And the way we looked at it was also in a similar kind of way, but we went sort of all the way to the end application. It's cool to be able to do 3D reconstruction, but can we find a use case where there is actually a tangible benefit and we're not competing with, for example, RealSense, just to name one well-known example. And so actually you're the first public audience I'm telling. So we're about to launch a development kit, which is basically our camera here combined with a pulsed laser. And this laser is being pulsed at 5 kilohertz. And you can basically extract 3D contours with 2 millisecond latency. So this is useful for a lot of applications in robotics where you need 3D information and you need to respond extremely quickly, right, to adjust your process. This could be to move the position of your cutting head or change some aspect of your welding or cutting or so on. So, I guess this is sort of clear, right? The type of thing we can do. And then that's not working. Let's try this video. Right, so you can see obviously you can't see that it's happening with 2 millisecond latency, but you can sort of see the real-time output. And this doesn't require any special processing hardware. That's important, right? We don't have to do any fancy custom FPGAs or any special ASICs to achieve this kind of performance. It's literally just our sensor and a CPU, right? So this opens up different opportunities for being able to create very low cost hardware able to do this very high speed 3D scanning. Yep. So yeah, this is open for pre-orders. So just contact me if you're interested. That's all I'd like to say. We're still growing. We were pretty happy early this year to win a couple of awards, which you can see there. And yep, I'm open for questions. Thanks.
Thank you very much. And I have to say, as soon as this whole thing goes back to normal, I'm going to Zurich. I'm visiting many of our members there. And I would like to pay you a visit because I am quite amazed on many things that you told us. The first thing is we've been talking today a lot about different applications. And today you were very clear. You told us there is a kit that you can use to target new applications. How does this kit look like? What kind of companies are we targeting to tell them, okay, use it and try to solve your headaches with it?
You mean what does the kit look like, or
yes.
Okay, I mean, the kit is literally a camera. Let me just grab it. There's one here.
All right, that's perfect.
Okay,
we're one of the first people in the world to see the kit that he's going to show.
Actually, no. So not this kit. So there's, this kit we launched at CES. That's one of the awards we won. Right. So you just go to the web shop, buy the kit, and download the software that's open source. So you just get started. You don't have to buy the kit to try out the software. You could download the software and get a data set from somewhere and start playing around. What we are launching now is basically a laser that bolts onto the side, and we have a module which works with our software so you can do your 3D scanning. Right. And so this is all about getting it out there, right? Seeing what people can create, trying to build confidence in the technology. And once the use case is well established, then working with different partners to really push it through to the final application.
We have had a really fantastic meeting. We are at the end, and I would like to close with Simone and with Kynan talking to us about applications. Dream away, your preferred future. If we had this meeting in, let's say, 2 years, what kind of applications that are for us unthinkable today you think they're going to be real in 2 years? I'm going to start with Simone here.
Excellent question. For this one, I was not prepared. I don't know. I mean, new applications, I cannot comment right now. Way to do application that already exists better, a lot. Maybe something that does not exist. I'm not sure that neuromorphic can play a role, but probably it's interesting. Would be holography, meaning to have 3D meetings. So right now we are doing a virtual meeting, right? But we are somehow 2D pictures. It would be nice if we can be in the same meeting room and everyone sees the 3D reconstruction, kind of Star Trek, if you want.
Kynan, what do you add to that? A couple of, let's say, Star Wars-like applications that people would get really excited, but you think they are really real in the coming 2 years?
Yeah, that's a tricky question, right? People only want to announce their applications once they're finished and on the market, right? So I think there's going to be sort of 2 tracks, right? There will be low volume applications where the time to market is reasonable, right? So industrial, right? That line scanner I just mentioned, right? You could imagine sticking that on a robot. It's not that hard to put something on the market, right? Because you don't have to deal with consumer grade. The margins are not that important, right? It's a reasonably high margin product. And there's a very clear benefit, right? If you can produce faster, then you can calculate the benefit, right? You're not having to deal with soft factors of consumer acceptance, and is there a use case really there? So I think this will happen regardless, right? The more sci-fi things are, oh, can we get this onto a phone, or can we get this into AR, VR, right? And sell hundreds of millions, and everybody's going to touch our technology. I think, I don't know if this has been raised already, but this will require more than one use case, right? There are 3 cameras on a phone. Adding another one adds another $10, $20 to the cost of that phone. So it better do more than one thing, right? And so everybody in the space is looking at what those more than one things are to justify adding $10, $20 to the BOM.
Excellent. I'm going to go now to Therapy. I'm going to go to Greg. The meeting is about to be finished. We always finish on time at Epic. What did you get out of this meeting? We talk about the whole supply chain on neuromorphic and time of flight. We talk about the optics, the lasers, the assembly, the no-moving parts, and we finish with a very, very big success story, which is innovation. What did you get out of this? What kind of learning points, takeaways?
So for me, just so everybody's kind of clear, my role is usually sales and marketing. So, I'm not a photonics engineer by any means. So for me, it's been a fascinating insight and a fascinating overview. And what I really got from this was kind of what I expected, which is that you're very keen on trying to connect businesses to make connections and sort of get beyond the academic to some real tangible value. So that I very much appreciated. So I've got some people to follow up with following the meeting. There's been some insights for some new technology, which I would like to put under the nose of our CTO. And at a personal level, I've met some interesting and new people, and enjoyed the exposure to the new technology as well.
And I enjoy having you in the meeting. Norbert, from SAIS, the giant SAIS, what kind of learning points, takeaways are you bringing home from this meeting?
It's true, as Greg said, it's so many different aspects are covered in this meeting, and it's fascinating how many different companies work on that topic with a different focus. And it's all about applications. We talked about this in different ways. And yeah, this is a good and really, really good question. What are the driving applications in 2 or 3 years? But nevertheless, it was a wonderful meeting regarding different pieces of technology that were shown.
I can actually try to bring them together. And before I do that, I want to finish the meeting with my friend Simon from Jabil. So we have a lot of pieces of the puzzle here. And in my opinion, you are the one who can put them together. If you could summarize 1 or 2 learning points, takeaways that you could bring to the weekend after this?
Yes, other than looking at new and even more innovative applications, just stick with the ones we have ahead of us. There's a lot of issues to be solved. I've seen a few interesting approaches today. Those meetings are usually very technology driven, which is okay, but you need somebody to take all the single technologies all together, integrated into workable systems in mass production. That's what Jabil can do.
I took a lot of notes because basically I'm sick of that. I love taking notes everywhere I go, and I took a lot of notes. I took a lot of learning points today. I'm going to show you what, my messy head looks like after the meeting. I really realized between the lines, all of you were talking about, it is about having very high dynamic range for the sensors, about having sensors with very high dynamic range. And there were a lot of pieces of the puzzle to actually put something together. The first one was about the multi-level optics. On that, I really love the presentation from EVG and the comments from SUS and the comments from Nanoscribe on what kind of multi-level optics we need and what kind of manufacturing process can make them. And I'm so happy to say that I do honestly believe that we have the best multi-level optics possible right now manufactured in Europe. And if you ask me, around Switzerland, actually right now we had the best multi-level optics that can be made. So I'm extremely happy with that. In addition, we talk a lot about the filters and the coatings and the selectivity and definitely the applicability of the filters to these very, very complex optics. And I think that goes to a potential very interesting collaboration between some of you, and I think you're going to follow up on that. The light source, we talk about the big set, 940 nanometer for structured light. That was something that is in the Santa Claus Christmas list of many of you. And Teravi told us, no, I actually am very happy with my near infrared LED. For many of our applications, and we could talk about applications later, this actually fits very, very well what we're looking for. On the neuromorphic cameras, ultra fast scanning, data processing, but what I saw from PROPHESEE, a very strong statement, say it's not only about data processing, increasing data processing, but it's about reduce the software complexity, investment on making simpler calculations. That was one of my biggest learning points as well. And then we had of course, the innovation comment, automotive, outdoor proof usage, qualification of the components, addition everything into a sheet that can solve everything. And there is, of course, a lot of room to cover. Still, we couldn't cover that in 2.5 hours, but we did some of that. For me, in every meeting, we have a new thing, the next big thing, and I was quite amazed with the presentation from LioniX on the different steerable adaptive lighting solutions that they managed to make with a photonic integrated circuit. Once again, we are talking about a piece of semiconductor silicon nitride from a wafer. What they managed to do for me is out of this world, and it was, congratulations, LioniX, quite amazing. Applications, I was super happy with Greg's comment about people counting on with the time of flight, with 3 meters away from the people. You guys have the chance to see the Teravi camera in the website. It's fascinating. I really love their technology. Greg, thank you for being here. And we talk a lot about applications. We have liked to talk even more. But for those of you who want to try their own applications, we have now a test kit available from Innovation and a fantastic group of new friends being made on a Friday afternoon. It is time for a great weekend. Have a fantastic weekend, and soon we'll have neuromorphic cameras to testify. See you soon. Take care. I love you. I really love you. I'm having so much fun with these meetings. Take care. Until the next time. Bye-bye.
Thank you, everybody. Thank you.
Bye-bye.
Thank you. Bye-bye.
Thanks, bye.